Ever wondered what would happen if an airplane engine just stopped mid-flight? Would the plane just fall out of the sky? The answer might surprise you, and it's way less dramatic than what you see in the movies. Today, we're going to bust some myths and reveal the incredible engineering and training that keeps you safe. Thousands of feet in the air. Let us start with a mind-blowing fact. A commercial airliner can not only continue flying if one engine fails, but it can also take off, climb to a safe altitude, cruise for hundreds of miles, and land perfectly safely with just one operating engine. How is this possible? It all comes down to a global standard called ETOPS, which stands for Extended Range Twin Engine Operations Performance Standards. That's a mouthful, but what it basically means is that modern twin-engine jets, like the Boeing 787 or Airbus A350, are certified to fly on routes that are a certain distance away from the nearest suitable airport. This certification is only granted after rigorous testing proves the aircraft can safely fly for hours on a single engine. Think of it this way. That second engine isn't there because the plane needs to fly. It's there for redundancy. It's a backup, a safety net. The aircraft is designed from the ground up to be fully controllable and operational with just one engine. In fact, during certification, test pilots intentionally shut down an engine right at the most critical moment of takeoff to prove the plane can handle it. They have to demonstrate that the plane can still climb and fly away safely. So, the plane you're flying on has already proven it can perform this feat before it ever carried a single passenger. So, what actually happens in the cockpit the moment an engine fails? Let's say the left engine goes out. Instantly, the massive thrust from that side disappears. The right engine is still pushing forward, which creates an imbalance. This is called asymmetric thrust, and it causes the airplane's nose to want to turn, or yaw, towards the dead engine. It's like trying to paddle a canoe with only one oar on one side. You'd just go in circles. At the same time, the wing with the failed engine loses a bit of lift and wants to roll downwards. This might sound alarming, but for a trained pilot, it's a scenario they have practiced over and over again in a simulator. Their first actions are immediate and almost instinctual. To counteract the yaw, the pilot presses the rudder pedal on the side of the good engine. This pushes the tail in one direction and keeps the nose pointing straight ahead. To stop the roll, they use the ailerons on the wings. Just like turning a steering wheel, to level the aircraft. Within seconds, the plane is stabilized. Simultaneously, the flight management system or the pilot will increase the thrust on the remaining engine to compensate for the lost power. Now, with the rudder deflecting and the ailerons adjusted, the plane is flying straight, but it's not very efficient. The pilot is constantly applying pressure to the controls to fight the asymmetry. To fix this, they use something called trim. The rudder trim is adjusted to hold the rudder in place electronically, so the pilot doesn't have to keep their foot on the pedal for the rest of the flight. This effectively rebalances the airplane for single-engine flight. It's an amazing piece of engineering that makes a complex situation manageable. Once the aircraft is stable and under control, the pilots run through a checklist. This is a calm, methodical process. They confirm which engine has failed, and then they take steps to shut it down completely to prevent any further damage. They'll secure it by cutting off its fuel and electrical supply. After that, they assess the situation. They communicate with air traffic control, declare an emergency to get priority handling, and identify the nearest suitable airport for landing. They aren't in a frantic rush to get on the ground. They have plenty of time. A modern jet can fly for hours on one engine. The main consideration is that the plane can't maintain its original high cruising altitude, so they will descend to a lower, more efficient altitude for single-engine flight, which is still well above any mountains or obstacles. Still not convinced? Let us talk about one of the most famous incidents in aviation history, Air Transat Flight 236. In 2001, this Airbus A330 was flying over the Atlantic Ocean when it suffered a fuel leak and lost power in both engines. The plane became a 135-ton glider. There was no thrust at all. Yet, the pilots managed to glide the aircraft for over 120 kilometers and land it safely at a military base in the Azores. Miraculously, everyone survived. This incredible feat demonstrates the fundamental aerodynamic stability of modern aircraft. Now, if a plane can be landed with 0 engines, imagine how much easier and safer it is to land with one fully functioning engine. An engine failure is an inconvenience, not a catastrophe. Next time you're on a flight and you hear the engine spooling up for takeoff, remember what you learned today. You're not on a fragile machine held up by 2 engines that must work perfectly. You're in an incredibly robust and redundant aircraft, flown by highly trained professionals who practice for these exact scenarios. The design, the regulations, and the training all come together to create a system that is, by far, the safest way to travel. The truth is, the odds of a single engine failing are incredibly low, and the odds of that failure leading to a serious incident are even lower. So sit back, relax, and enjoy the view from 35,000 feet. If this video helped ease your mind about flying, do us a favor and hit that like button and subscribe to Aeromind. Share this with a friend who gets nervous before a flight. It might just change how they feel. We have so much more to explore about the amazing world of aviation. Thanks for watching, and we'll see you in the next one.